For number 16, we want to factor f of x into linear factors given that k is a 0 of f of x. To do this, since k equals 7, we're going to set up a synthetic division using a 7 in the box and writing the coefficients for the polynomial 1x to the third minus 4x to the second minus 49x plus 196. We bring down the first term, multiply and add, multiply and add, and multiply and add. We get a remainder of 0. So we know that k equals 7 is a 0 of the polynomial, and that means x minus 7 is a factor. So you can factor this original polynomial, which was an x to the third. You can write it as an x minus 7 factored out with what's left over under the line for synthetic division. Since this was an x to the third and we factored out an x, we're going to have x to the second plus 3x minus 28. That is the one factorization of that polynomial. Now we want to completely factor it. So this polynomial here is a trinomial, and with a leading coefficient of 1, we can factor it by finding factors of negative 28 that will add up to positive 3. The pair of factors that adds up to positive 3 would be positive 7 and negative 4. Multiplied give you negative 28, added will give you positive 3. So our factors are x minus 7, x plus 7, and x minus 4. And they could be in any order. So we're going to choose D for our answer. For number 17, we want to find all rational zeros and factor f of x. Now it would be nice if they told us what one of those zeros is. Since that's not the case, we need to use the rational root theorem that says if you have any rational zeros, they are factors of the last term divided by factors of the leading coefficient. So our possible rational zeros are factors of negative 108. Now there's a lot of numbers that go into negative 108. So the things that we would try in synthetic division would be plus or minus 1, plus or minus 2, 3, 4, and all of these are positive or negatives. 6, 9. Now this is a list of all the factors of negative 108. These are all the numbers that go into 108 evenly without leaving any remainders. So it's quite a big list, especially when you consider the positives and the negatives. So we're going to do a little shortcut here and notice that in my choices, if I were to try positive 1 and get a remainder of 0, that doesn't match with any of the choices. So if you weren't given any choices, you would do the setup with synthetic division using the coefficients 1x to the third, 3x to the second, minus 36, minus 108. I would start with a positive 1 in the box. Now, if you go through the process, you won't get a remainder of 0 with 1. So you can eliminate positive 1 as a possible rational 0. We would also have to eliminate negative 1 and positive 2 and negative 2. So let's try positive 3. If we put, let's go back. Let's do positive 3 in the box and see if positive 3 is a rational 0. So if I bring down the first term, I multiply, add, and so on. Get 3, 6, 18, negative 18, and minus 3, that's negative 54. Okay, so that is, we can eliminate positive 3 as a possible rational zero. So I'm going to go back and try -3. This is a good time to use an eraser. I'm going to try -3 in the box, and I bring down the first term, 1, multiply -3, get 0, multiply, add, multiply, and add, we get a remainder of 0. So that means -3 is a rational zero. That also means that x plus 3 is a factor of that polynomial. Since our polynomial started off with an x to the third power, when we write the result of the synthetic division, we are going to start with the second power. So it's going to be 1x to the second power minus 36. Now this is not completely factored. We want to continue to factor it. You should recognize this as a difference of two perfect squares, so we can factor even further. The factors of -36 that will add up to 0 are x plus 6 and x minus 6. So these are your three factors, and then we set each of those factors equal to 0. X plus 3 equals 0, and we get x equals -3. X plus 6 equals 0, or x equals -6, and x minus 6 equals 0, or x equals +6. So our answer here is choice B. We have the three zeros that are the rational zeros, and we have the polynomial in factored form.